multiplication of vectors. There are two types of vector multiplication. They are one, scalar product, which is also known as dot product. And we have vector product, which is also known as cross product. The scalar product is so called because after carrying out the multiplication, the answer becomes a scalar. And the vector product is also called vector product because after carrying out the multiplication, what you have is also a vector. So let's look at the scalar product of vectors. Now, the scalar product of two vectors A and B is given as A dot B is equal to magnitude of A, magnitude of B cos theta. This is how it is being done. Now, take note that when you are carrying out the dot product, it means that you can carry out the dot product of two vectors by either multiplying, carrying out the dot product of the A and B, or taking the magnitude of A, taking the magnitude of B times cos theta. Either of these two ways will give you the same answer, and that's how to carry out the dot product. You either use this method or use this method. One thing to take note of here is that when doing dot product, that note I dot I is equal to same as J dot J, which is also equal to K dot K, and that is just 1. When you dot two i's together, you get 1. Dot two j together, you get 1. When you dot two k together, you get 1. And when you dot other different ones, I dot j for instance, or j dot k, or k dot I, you will get 0. When you dot two different vectors, you get 0. So if you dot j dot I, you get 0. Once they are different, but they are the same, they will give you 1. So we'll look at example on this. But another thing I want to take note also is that, you see, when two vectors are 90 degree or perpendicular or orthogonal to one another, their dot product is 0. And that's simply because, you see, this angle here is the angle between the two vectors A and B. Now, if this is 90 degree, obviously 90 degree is 0. It makes everything here 0. That's why their dot product will give you 0. Take note of that. Let's take an example now. Let's take example 1 on dot products now of vector or scalar products. We are given that if A is equal to 7i minus 3j plus 2k and B is given as 4i plus 5j minus 3k, find the magnitude of A and B, 1, the scalar product of A and B, and then the angle between A and B. Let's take this now. For the first one, looking at for magnitude of A. First, magnitude of A. Now, that will be 7 square plus minus 3 square plus 2 square, all into square root, and we'll get what this will be. I'll come back with the answer. The magnitude of B is going to give us 4 square plus 5 square plus minus 3 square, all into square root. So let's put down the answers now. This gives us root 62, and this gives us root 50. That's about that. You can you can choose to express this in decimal. That will be 7 point something as well. But we can leave the answer in a short form like this. That's not still bad. Number 2, the scalar product of A and B. A dot B, that's scalar product. And that will give us 7i minus 3j plus 2k dot 4i plus 5j minus 3k. Now, take note of something here. If you want to actually carry out the dot product of this is how to do it. Just say, let me do that here briefly. Now, what you're supposed to say is to say 7 times 8, 7 times 4, that's 28. Then I dot I, that will give you 1. Then 7 times 5, 35. I dot J, that will give you 0. Then 7 times minus 3, that is minus 21. Then I dot K, that will still give you 0, because I'm dotting two different things. Remember our rule. Minus 3 times 4, that is minus 12. Then J dot I, that's 0. Plus minus 3 times 5, that's minus 15. Then J dot J, that will give you 1. Then plus again, minus 3 times minus 3, that's 9. And then J dot K, that will give you 0. So lastly, 2 times 4, that's 8. K dot I, that's 0. 2 times 5, that's 10. K dot J, that's 0. Plus lastly, 2 times minus 3, that's minus 6. K dot K, that's 0. So at the end of this, everyone that has 0 goes off. So this should give us 1 because it is K dot K. So this is minus 6 into K dot K, that's 1. At the end of the day, all we have left is this, and this. And that will be 28 minus 15 minus 6. You see, this is a very long way of doing this. All you just need to do is to say, just multiply the I with the I alone. 7 times 4, 28. I dot I, 1. That's all. 28 times 1 is 28. Then go with the J and J. Because you know that when you multiply, when you dot I with any other one, it will give you 0 because I dot J will give you 0, I dot K will give you 0. So don't only multiply I with the I alone, 28. Minus 3 times 5, that's 15. J dot J, 1. Then 2 times minus 3, minus 6. K dot K, 1 also. That will give you 6 times 1, that's 6. So this is what we have. At the end of the day, this will give us just 7. So that's the easier way to do it than to do it one after the other of carrying out multiplication. That will be a long stress. So this is how you just carry out dot product. Now lastly is to find the angle between the two vectors. Remember we have it that A dot B is equal to magnitude of A, magnitude of B, cos what now? Cos theta. So you can say that cos theta is simply A dot B over magnitude of A, magnitude of B. Now what's A dot B we've got? That's 7. What's magnitude of A? Root 50 times what's magnitude of B? Root 62. If we do this, we get that cos theta is equal to 0.1257. And theta therefore will give us cos inverse of 0.1257. And that will be 83 degrees approximately. So that's that about this. Example 2. You will soon go outside now. If vector C, which is I plus J plus KD, and vector D, which is ID minus 2J plus 2KD. Example 2. If vector C is given as I plus J plus KD, and vector D is given as ID minus 2J plus 2KD. For what values of D are those vectors? Are these vectors orthogonal? Let's solve this question. Very simple. We have it that if two vectors are orthogonal, then C dot D, their dot product should give us 0. So let's take their dot product now. That is I plus J plus KD dot I D minus 2J plus 2KD should give us 0. So this 1I and this DI. So 1 times D, that will give us D. Because the coefficient here is D and coefficient here is 1. That will give us D. I dot I will give us 1. So 1 times D will give us D. That's good. Now, here is 1. 1 times minus 2. That's minus 2. Then J dot J, that's 1. Next is D times 2D here will give us 2D. And then K dot K will give us 1. So everything here is equal to 0. This 2D square, please. So at the end of the day, we solve simultaneously, quadratically. 2D square plus D minus 2 is equal to 0. Now, solving by quadratic method, we have that D is equal to. So solving this quadratic equation, I just use a calculator to solve actually. But you can solve by formula method or complete square method, you still have the same answer. We have that our D is equal to minus 1.28 or D is equal to 0.78. That's the value for our D. Vector products or cross products. So this so-called because whenever you carry out vector product of two vectors, the result would always be a vector. That's why it's called vector product. You see, the vector product of two vectors, say A and B, is given as magnitude of A cross B is equal to magnitude of A, magnitude of B, sine theta, where theta is the angle between the two vectors. So magnitude of A cross B is given as magnitude of A times magnitude of B times sine theta. Now, another thing to note here is that we have this to help you remember how to cross two products. We have this like this. You see, we have it that I cross J will give us K. And then we have it that J cross K would give us I. And then K cross I will give us J. Now, mind you, if you go the other way around, because this is going like this, it's going like this in an anti-clockwise manner. Now, if you go clockwise manner, I mean, you say J cross I. Also, J cross I will give you minus K. Take note of that. And then I cross K will give you minus J. When you go the opposite direction, you get a negative value. And if you say K cross J, you get minus I. Now, lastly, another thing I want to take note of here is that, you see, I cross I, J cross J, K cross K. When you cross two same thing, you get 0. Unlike dot. When you dot two same vectors, you get 1. But if you cross two same vector, I and I, J and J and K and K, you get 0. So that's that about that. Well, the cross product of two vectors can also be done using matrix. And we'll show all of those too. So take note of that. Example 1, two vectors acting in different directions are given by A, which is 2i plus 3j plus k, and B as I minus 6j plus k. Find the cross product of the two vectors A and B and the angle between the two vectors. Now, I'm going to solve with the method I gave to you of crossing two products now. Now, take note of this. Remember this, that we have I, J, and K. So if you say A cross B, this will give us 2I plus 3j plus k cross I minus 6j plus k. So let's begin now. 2 times 1 will give me 2. I cross I, when you cross two same thing, you get 0. This is 0. Let's go again. 2 again times minus 6. That is minus 12. Now, I cross j. Check it there now. I cross j. That will give me k. Next, or let me put it like this. K. Now again, lastly, 2 times the coefficient of this k here, that is 1. I will get 2. Then I cross k. I cross k. This is supposed to go like this. Take note. So I cross k, when you are going in opposite direction, like this, I cross k, you get minus j. So this is like minus j. Then let's go again now. Let's now go with 3 now. 3 times 1, that's 3. J cross I. J cross I. You are going in the opposite direction. That will be minus k. Then again, that same 3 again. 3 times minus 6. That's minus 18. And then j cross j. That will give you 0. Now, 3 times 1. That's 3. And j cross k. J cross k, that will give you I. Now lastly, let's go with the k. 1 times 1 here, that's 1. K, that's 1. K cross I will give us j. That's 1j, which is same thing as j. Now, 1 times minus 6, that's minus 6. Then k cross j. K cross j, we are going in opposite direction, that will give us minus I. And then lastly, we have 1 times 1, that's 1. And k cross k, that's 0. This goes off, and this goes off. We are left with A cross B being minus 12k, then minus 2j, then minus 3k, again plus 3i, again plus j, and then plus 6i. Eventually, this will give us 6i plus 3i, that's 9i. And then minus 2j plus j, that's minus j. And then 12k minus 3k, that's minus 15k. So this is A cross B. Now, method 2, this is actually the quickest method to solve, is to solve by matrix. A cross B, just do like this. I, J, and K. Now, take your I first, don't take B. A first, the first thing you write is that what you write. So my A is 2, 3, and 1. Then 2I, 2 under I, 3 under J, and 1 under K. Now, for the B, 1I minus 6 and plus 1. Then you take the determinant of this. Plus, minus, plus, don't forget to look for determinant. This is going to be close here and here. This 3 times 1, that's 3. Minus 6 times this, that's minus 6. This is our I. Then minus j, I'll put the I here, then minus j into close here and here, you get 2 times 1, that's 2, minus 1 times 1, that's 1. Then plus k into close here and here, 2 times minus 6, minus 12, minus 1 times 3, that's 3. So at the end of the day, this will give us 9, because 3 minus minus, that's 3 plus 6, that's 9i. This is 2 minus 1, that's 1. 1 times minus j will give us minus j. And then minus 12 minus, that's minus 15k. Which is what we have here. So this is very, very fast. We can use method of determinant to look for this. Now, though we're not asked to do this, but we need it when we're looking for the angle. So let's talk about the angle first of all. To get the angle, we have to do magnitude of A. I'm looking for the I'm done with the first part, the cross product. Magnitude of A, that is going to give us 2 squared plus 3 squared plus 1 squared, all into square roots. And this is going to give us 4 plus 9, 13 plus 1, that's 14. So again, let's look for magnitude of B. Magnitude of B is going to give us 1 squared plus minus 6 squared plus 1 squared, all into square roots. This is going to give us root of 38. Now, to get the angle, we have to say, let's go and look for magnitude of A cross B. Our A cross B, look for the magnitude. And this is our A cross B. These are our results for A cross B. So, and this is it here. Same thing. That will be 9 squared plus minus 1 squared plus 15 squared, all into square roots. 225 plus 81, that's 301, 302 square roots. So we are done with this now. Now let's go and look for our angle. Remember that magnitude of A cross B is equal to magnitude of A, magnitude of B times sine theta. So I need theta now. That's what the question says I should look for. I already have this 302 is equal to magnitude of A, that is root 14, times magnitude of B, that's root 38, then times sine theta. So dividing here now by root of 14 times root of 38 over root of 14 likewise times root of 38. This eliminates this. So we have that sine theta is simply going to be equal to, I'm sorry, there's a little mistake here. This is 307, not 302. Just get to confirm that. 307. So this is going to give us 0.76. So theta will simply be sine inverse of 0.76. This is 49.46 degree. That's the angle between the two vectors. Now, one thing you need to also know is that even you've done this using the dot products, you still have the same angle, actually. Just that your A dot B will not give you this, because this is A cross B, and that would have been A dot B, but you get the same angle.